Hi, welcome to an introduction to vectors as part of the Mechanics 1 A-level module. Okay, to start, a vector is something that has both direction and magnitude. An example of this can be demonstrated from my friend here, Bob. If Bob is travelling along here, we would say he has a certain speed. Now, he could be moving this way and still have a certain speed, this way, round, anywhere he likes, and he would still have a positive speed. However, if we talk about the word velocity, velocity has both magnitude or size and direction. So if Bob is travelling along this direction, we could say he has positive velocity, whereas if he decides to go this way, he has negative velocity. So velocity is a good example of a vector as it has both magnitude and direction. Now if we look here, we have these vectors represented by these lines here, all these three lines. This we've defined as vector A, and as you can see here, we underline a vector to show that it's a vector. That's notation we use. Now another way vectors can be thought of is as forces. If Bob is pushing here in this direction with a force that's relative to the length of this arrow, okay, that could be a vector. We could say that's vector A. Now if this is vector A, if Bob then pushes with the same magnitude or force but in the opposite direction, we would say this is vector minus A. If Bob wishes to push in this direction, it's the same direction as A, but twice as hard. It's pushing twice as hard, the vector is twice as long. We would say this is vector 2A. Now you can also manipulate vectors and add and subtract them from each other. If we have here the vector A, and I wish to add the vector B to it, all I do is I simply take the vector B and add it on to the end of vector A, and I end up with this new vector here, which I can call A plus B. I could, if I wished, take vectors away. The vector A minus B would be the vector A here, and then if I want minus B, this is the vector B, I need it to go in the other direction. That's meant to be vector B. Okay, so I have a vector B here, which would be going in the other direction. So if I have the vector A minus B, I'm going from A and then taking away B. That would create for me the new vector here, A minus B. So as you can see, it's very easy to add and subtract vectors. You can think of it as kind of travelling along in a diagram. Instead of going from A to B, you're just going down here. Or in a force sense, instead of pushing with this force and at the same time pushing with this force in this direction, is the same as pushing in this direction with this force. Okay, so let's have a look at other uses of vectors. Now we can write vectors in what we call component parts. This is split into the I direction and the J direction, and we would simply here say the vector A, because it goes along to 3 on the I direction, is equal to 3I and 4 on the J direction plus 4J. This symbol here, where you have a vertical straight line either side of the vector, means magnitude or size of the vector. And all we do there is think of this as Pythagoras. We're trying to work out the length of the hypotenuse. So in this case, this is 3, this is 4. We can see that we would square 3, we would square 4, and square root the answer to get the magnitude of the vector, which in this case is 5. So these two lines here mean the magnitude or size of the vector, and we can split the vector into component parts I and j. Now we can also add and subtract vectors in their I and j sense. If we take the vector b down to this example, no, let's leave it there for a moment. Oh, we've got a vector c that we'll use. Let's take the vector c and see what happens when we add it to vector a. Now, vector a is 3i plus 4j, as we can see from the diagram. Vector c says here is 4i minus j. So it's 4 along the I-axis, which would take this to 7, and minus 1 on the j-axis, which would take this to 3. So vector A is that. Vector C, as we've just seen, is 4i minus j. Now, if I wanted the vector A plus C, I would simply add these together to get 7i plus 3j. And if we check on the diagram, the vector A plus C is actually here, isn't it? A plus C, and that is at 7i 3j. Okay, the final and actually most used skill with vectors is to put it back into its component parts. We have here, say, a force of 4 newtons acting in direction of 30 degrees to the I direction. Now, to put this back into its component parts, all I would need to do is use trigonometry. Now, 4 we know is the hypotenuse. Relative to this angle, the j component is the opposite. Let's call that y for the moment. And the I component is the horizontal. Let's call that x for the moment. Now, all I'm doing here, let's say I need to find x. So I know this vector here of 4 newtons can be split into its component parts of xi plus yj. So to find x, that's adjacent to the angle. Adjacent and hypotenuse is cosine. I know the cos of 30 degrees is equal to the adjacent, which is x, divided by the hypotenuse, which is 4. So I know x is equal to 4 lots of cosine of 30, which is a 3.5 to 1 decimal place. So my vector, 4 newtons, I know the horizontal component is 3.5i. To work out the vertical component using trigonometry again, this y is opposite the angle of 30, so I know that I would use sine. The sine of 30 is the opposite side, which is y, divided by the hypotenuse of 4. So y is equal to 4 lots of sine 30, which is 2. So the j component of my vector is 3.5i plus 2j. So this is what I will be writing there. Okay, thanks for listening, and thank you to Bob for all his help. I hope to see you in part 2 of vectors.